Let's talk about incorrect theories. Longer path or equal transit, skipping stone, and Venturi theory. It's okay. The theories are not that hard to learn. Ha! Psych! Okay, so moving on, lift controversies. And number 1, longer path or equal transit time theory. Now let's begin. Hi teacher, I have a question. What part of the plane are we talking about? So, this is the part that we will be examining today. This part is the shape of an airplane's wing, also known as an airfoil. So, this is a basic shape of what it looks like. Let's The theory in summary is when air molecules are split at the leading edge of an airfoil, they must meet up at that trailing edge. Air flowing over the top of the wing has to cover a greater distance than the air on the bottom. Therefore, it has to go faster to rejoin the slipstream, thus creating a low pressure on the top of the wing. The difference in pressure creates lift. In simpler terms, the theory states that airfoils are shaped with the upper surface longer than the bottom. In order to meet up at the trailing edge, the molecules going over the top of the wing must travel faster than the molecules moving under the wing, because the upper flow is faster. From Bernoulli's equation, the pressure is lower. The differences between pressures produce lifting airfoils are designed to have the upper surface longer than the bottom. This is not always correct because in cases when the upper and bottom surfaces have the same length, it showed plenty of lift. The importance is turning, not the distance. This wouldn't answer cases when planes fly upside down, for example, stunt planes, because then it would be switched. Air molecules travel faster over the top to meet molecules moving underneath at the trailing edge. The flow over the top of a lifting airfoil does travel faster than the flow beneath the airfoil, but the flow is much faster than the speed required to have the molecules meet up at the trailing edge. We can calculate a velocity based on this assumption, and use Bernoulli's equation to compute the pressure and perform the pressure area calculation, and the answer we got does not agree with the lift that we measure for a given airfoil. The lift predicted by the theory is much less than the observed lift because the velocity is too low. The actual velocity over the top of an airfoil is much faster than that predicted by the longer path theory, and particles moving over the top arrive at the trailing edge before particles moving under the airfoil, therefore making it incorrect. The upper flow is faster, and from Bernoulli's equation the pressure is lower. The difference in pressure across the airfoil produces the lift. This part of the theory is correct. The flow over the top of a lifting airfoil does travel faster than the flow beneath the airfoil, but the flow is much faster than the speed required to have the molecules meet up at the trailing edge. This concludes the Number 2, the skipping stone theory. Lift is the result of a simple action-reaction as air molecules strike the bottom of the airfoil. Like putting your hand out of the car window while it's moving, the impact of the air striking the lower surface of the wing pushes the wing forward, creating lift. The theory holds that the lower surface of the wing is what creates lift, and the upper surface contributes little to no lift, since it is out of the direct airflow, because this is similar to the way in which a flat. Why exactly is it incorrect? Well, it assumes that all of the flow turning and therefore all of the lift is produced by the lower surface. However, the upper surface also turns the flow. Usually there is actually more flow on the upper surface than the lower surface. And despite that, On the top of the airflow, no vacuum exists. Molecules are still in constant random motion on the upper surface, as well as the lower surface, and these molecules strike the surface and impart momentum to the airfoil as well. Using the knowledge of air density and the number of molecules in a given volume of air, the predictions are totally inaccurate when compared to actual measurements, concluding that the main problem in this entire theory is that it neglects the physical properties of the fluid. Lift is created by turning a moving fluid, and all parts of the solid object. The Venturi theory. This goes against the longer path equal transit theory. Bernoulli found that when fluid goes through a pipe that is squeezed in the middle, known as the Venturi, the fluid's velocity increases and its pressure decreases. The upper surface of the airfoil acts like the nozzle that he created, constricting the airflow. The airflow speeds up, which according to Bernoulli causes a decrease in pressure on the upper surface, creating lift. Since the airflow is not restricted below the wing, the pressure is not affected and does little to create lift. This is incorrect because the theory is based on an analysis of a Venturi nozzle, but an airfoil is not a Venturi nozzle. There is no phantom surface to produce the other half of the nozzle. And we've noted that the velocity gradually decreases as you move away from the airfoil, eventually approaching the free stream velocity. This is not the velocity found along the center line of a nozzle, which is typically higher than the velocity along the wall. This theory deals with only the pressure and velocity along the upper surface of the airfoil and neglects the shape of the lower surface. Okay, so that'll be the end of the video. Or is it?